Hey everyone, and welcome to my channel. It's finally time to show you what I've done to fix the KRK speakers. I've tried everything I could to fix them and even used a friend's workshop. He had a lot of tools there and we spent a lot of time messing with things, but unfortunately all of this was in vain. I'll still show you everything that I've tried just to have this as a do not replicate in case you want to fix them as well. Okay, now let's move on to the video. First things first, I took the speaker and disassembled the whole thing. To do this, you simply unscrew some screws on the back panel and then the whole panel comes off. After removing the panel, you then can disconnect the 10-inch driver and the other two drivers which are combined in one cable. And finally, the LED cable used to light up the logo on the front. My theory before doing all this was that the power supply, which sits very close to the amplifier and crossover, was inducing electromagnetic interference, EMI in short, on both components. I thought due to the power supply being a switching power supply that it will generate more EMI noise and mess with the signal. And somehow this interference gets picked up by the amplifier and amplified all the way to the drivers. Or at least that's what I thought. What I did was went to my friend's workshop so we could cut a thick piece of aluminum to insert in between the power supply and the rest of the components. This will be good for our use case because all conductive materials conduct EMI as well, and the thicker they are, the better. This is his father's workshop that we were using to do all the modifications. It had all the necessary tools and as a bonus there was a German Shepherd dog included. I tear down and separated all the components from the panel of the speaker and noticed a crashed capacitor. We tested it and it was working fine. After all, the panel had a quality control pass sticker for a reason. I also removed the heatsink of the amp or the crossover chip. Not sure which one of the two was it. This was to repaste the chip and make sure it had good thermal conductivity between the chip and the heatsink. We started by cutting a large piece of recycled aluminum and then sanding it down to remove some of its paint. We cut that piece into two pieces for the two speakers. We sanded down the edges so they are not so sharp, then making a cutout for the connector. The only thing left to do is to completely remove the paint on it to be as effective as possible in removing the EMI. And finally, we're sanding it down to have only the bare aluminum left. I took the metals home and started installing heatsinks on almost all the heat generating components. I used thermal glue to stick the metal in between the two boards and used soundproof foam to isolate it. I repasted the aluminum heatsink that was being used to cool the chip and added thermal pads for the capacitors to transfer their heat to the back plate as well. I made a huge mess, as you can see here, because I was trying to find the right size of heatsinks for every component. Unfortunately, this method didn't work, so my other theory was that the connection between them was too short and that it was letting the frequencies travel through vibrations. Either way, it was back to the drawing board, which meant I had to go back to my friend's workshop. We started off by drilling holes on the backplate so we could mount the board further away from the power supply. Also, we bought some cables so that we can connect the two components together because now they were going to be further apart. Our idea was to create distance between them and to create a faraday cage around the board that needed protection from EMI. For the faraday cage, I bought some conductive fabric that could absorb the frequencies from the power supply. We proceeded to cut some wood to make the base. The idea was to make a little house for the board and cover it with conductive fabric. That way we can achieve almost 100% coverage of the whole component. Then we came up with the idea to sew the fabric together to get as much coverage as possible. As you can see, it turned out good. And before doing all this, we actually tested the conductive fabric by putting one of our phones inside and trying to call the number. With just one layer of fabric covering the whole phone, the number was out of service. Here you see me arranging the cables and making sure to group them together. These are some generic female to male cables we found from AliExpress, so we can have some distance between the electronics as I said before. We installed standoffs for the new holes we drilled and then proceeded to install the board. Now for the wooden pieces, we used hot glue and a nail gun to make sure that they are connected together. Then we hot glued it around the board to make sure everything fit. And finally, we added the fabric on top with, of course, some hot glue. And as you can see, it fits like a glove. We plugged just a power cable to test the speaker, and unfortunately, it was still hissing like on day one. No difference at all. I was very disappointed that I couldn't make at least a small improvement, but clearly the problem lies elsewhere. I hope KRK fixes the problem with the hiss in their 5th generation, because these speakers are amazing for the price. I can still recommend them for their price, but obviously it will be much better if they didn't have this issue. I want to say thank you for watching the video, and I'm sorry for the bad news, but it is what it is. I hope somebody can figure out where the hiss is coming from, and if they do, please share and let us know how we can fix this. If you enjoyed the video, please consider subscribing, liking, and share it with your friends. And until next time, farewell.